Okay. Should be able to. Okay, so I'm going to kind of hit a few things that gave us the most trouble on what we just did a minute ago. And then I'm going to start going straight through chapter 1, the review chapter. And it says review chapter, but there are certain topics in there that some of us might never have seen. I don't feel like that means anything. It just means that whoever you had before didn't teach that specific thing for whatever reason. Maybe it wasn't in the curriculum. So that's one reason why I cover it real quick. If there's something I'm covering quickly, I'm going a little too fast. Tell me to slow down. If I'm going too slow, just deal with it. Because somebody else thinks I'm going just fine. So a couple things that trouble us on the assignment we just looked at. From the very beginning, I think, and I understand why. Number 4 and 5 gave us trouble. And commutative versus associative. I'm not going to make a huge deal out of this because normally I am not very concerned about terminology as I am about are you able to do the work. Terminology becomes much more important once you get into levels of math where you start talking about different types of systems, but we're just going to deal with real numbers. Right? Commutative would be 8 plus 9 is the same as 9 plus 8. P plus Q is the same as Q plus P. Even 4 plus X plus W equals X plus 4 plus W. In each example, individual things move. Now, I'm specifically using addition. You saw an example. I could do the same thing with multiplication. Is there any operation that actually this would still be true for? 8 times 9 is the same thing as 9 times 8. Is 8 divided by 9 the same thing as 9 divided by 8? And you can tell that 8 divided by 9 is less than 1. 9 divided by 8 would be more than 1. They're obviously not the same. Subtraction, 8 minus 9, is that the same thing as 9 minus 8? No. Hell no. One's negative, one's positive. Very quickly you can see that's not true. So both of these only work for addition and multiplication. They don't work for division or subtraction. Associative would be, I'll take this example. Did any individual thing, the 4, the X, the W, did any of those switch places? No. What actually moved, or what actually changed? Parentheses. So parentheses associate. Individual things commute, like we all commuted to school today. Right? Commute just be commuting to work, commuting to school. You guys with me? A little bit? The other one, just wherever the parentheses get up and move. 3 times y times z is 3 times y times z. The parentheses got up and move, so that would be associativity. Again, if this is the only thing you have trouble with, then I am so happy. I'm not as concerned about terminology as I am about doing the work. Yeah.
So it's associative when only the parentheses move, and it's commutative when the numbers switch
When
around?
individual things, letters or numbers.
And do you ever solve it when you do this?
No, because this equality is given. This is this.
Okay.
This is not an equation in that sense. There's nothing to solve. This is actually a statement. This is the same as that.
Okay.
It's sort of the same thing as saying 4 plus 5 is 9. Is there something to solve there?
No.
It's a statement of fact. So these are all statements of fact.
Okay.
Cool. All right, good. Yes?
I'm sorry, did you say that commutative and associative only addition and multiplication for both of them?
Yes, exactly.
Oh, okay.
I like it. And we can try it out. If we do 8 divided by 4 versus 8 divided by 8 divided by 4. Now, if that's true, that would be an example of division that has which property? I kind of gave it away because I listed it there. So should it, because the parentheses we gave a move. What's 8? What do I do first here? Yeah, what's 8 divided by 8? 1. What's 1 divided by 4? 1/4, or 0.25, or whatever you would say. What do I do first over there? Parentheses. 8 divided by 2. 8 divided by 4 is 2. So now I get 8 divided by 2 is 4. Not 1/4. So those are not equal. So we've just proven that division is not associative. All we need to prove that it isn't that is to find one example where it doesn't work. There's one example it doesn't work. It basically doesn't work for almost everything. Except 1 divided by 1 divided by 1. So there's some trivial things that will work for, but it won't work for everything. You guys kind of... This is one of the least important things, but it's still important to understand what these words mean. Okay. The next thing I think that gave us trouble was where they said factor. And I wish they would have used a different word, because it really isn't factoring yet, because I don't think any of us have done a lot of factoring, really. That's one thing we're going to learn this semester, is how to do all these different forms of factoring. But if there's a problem like this, I think it was something like this, or something close to that, whatever it was. And how do you simplify this?
Distributed.
Yeah, so you bring a 7 to both. Now let me make this a better number. Sorry. Give me a second. You'll see why I'm doing this. Make it easier on me. Let's put a 2 out there. Okay. Not because I have trouble multiplying 7 to 5. That would be a bad sign for your math teacher. But it's because, why does distributive property work? This is a very good example of why I love to teach math, and this is exactly why you should feel completely free to ask me anything. Why does it work that way? Don't accept it. Just push me. Say, why does it work that way? So what do we have to do? Order operations would say you have to do what first? Parentheses. Can I do anything in there?
No.
Please, dear God, don't say 8x. Why can't I put those together? They are not like terms. So there's not a damn thing I can do in there. So order operations officially says, you're screwed. But we somehow do something. That should trouble you. You should be like, you said this, and then we did this, and what the hell? So, what does this really mean? This does not mean 2 times x. I know it does, but more than that. 2x is doing what? What does that really mean? Where do I get 2x from? How do I get 2x? I take an x, and I add another x, right? You guys with me? So what would 2y be? Y plus y. 2m. M plus m. Okay, enough there. So 2 of this. This plus this, right? 2 anything is that thing plus that thing. You with me? That's really the definition of multiplication. If I have 5 crates with 3 apples in each, I could do 3 plus 3. No, let's do multiplication. That's the kind of a shortcut, but it's based on addition. So if I have twice this, I write that thing twice. Then I can use commutativity and associativity and all that crap, or you just realize it's all addition, so who cares? I can add whatever order I want to. What's 5 plus 5? What's 3x plus 3x? So why would you do this? The shortcut is the appropriately named distributive property, right? Distribute the 2 to both. Have any of you ever seen that? Yes, good. I like it. Because that's one little thing that a lot of people don't ever show people is, why does distributive property work? Don't just accept it. Okay. Good. So, all that stuff, a lot of you guys did well with this distributive property, but I want to show you why it works. So, what do these both have in them? What do they share? There's no 6 and 10, but there's a 2 in both. And of course there's a 2 in both, because there's a 2 that I gave both of them. It's like, well, yeah, Jeff, you just did that. So if I had, I don't know, this, what number do they both have in them?
11.
They both have an 11 in them. So I'm really doing this in reverse. I'm saying what number would have been sitting out here and what would have been in here. There must have been an 11 out there, because I can see they both have an 11 in them. What must have been here to get 11?
1.
There must have been a 1 there. 11 times 1 would have been 11. And what must have been here to get this?
4x.
4x. So that's the easiest form of factoring. It's really just distributive property in reverse. You don't even have to call it factor yet, because when we hear factor, we think, whoa, well, no, this is just distribution in reverse. Not a big deal. Yeah.
So when you answer that problem, do you write it out like that, or would your answer be 11?
Your answer would be this. If they said, what's the greatest number that goes into both? 11. To factor this, you take the biggest number that goes into both, you take it out. So for example, another example, if I had what number comes out of both? 22 has what and what in it? 2 and 11. That's the only parts I can really play with. And of course it has a 22 in it that's given. 40 has what in common with that? 2. So the only thing I can take out is a 2. And what would have been here? Yeah, 2 times what is 22? 11. And there's a y. Minus, and there must have been a 20 here, because that's what I doubled to get 40. So it's really just distribution in reverse. You got to think backwards. What would have been here to get this? What would have been here to get this? And that's really what factoring is. It's doing it backwards. Figuring out what I had before to multiply to get this. And that's why factoring is more difficult, because you got to think backwards, right? So it's really the same as that 300 problem. You had to break it up. Right? You're trying to figure out what did I have to make this. This is almost the same thing, just a little bit more difficult because I throw some variables in there, right? To do that one, hopefully we didn't have too much trouble with that one, but the easy way is to do 100 times 3. And 100, of course, 10 times 10. And you just keep going until you get nothing but prime numbers. That's why it's called prime factorization. What's a prime number?
The number that you only go in with 1 in itself.
I like it. So like 17. I can only divide that by 1 or 17. That's not a very, it doesn't have a lot of parts to it. But 60 has got a lot of parts to it. 2 goes in, 3 goes in, 4 goes in, 5 goes in, 6 goes, holy shit. 7 doesn't go in, right? 8 doesn't go in, 9, then 10, 12, 14, 15, one of those two. Okay. All right. Let me think. Oh, yeah.
So with prime factorization, obviously it can vary, right? So as long as you can get the number that they're asking for with just prime numbers?
If you do it correctly, everybody will get the exact same answer. So what I mean by that is it's not arbitrary as to where you stop. So I know I stopped at 10 times 10, but I didn't stop because it was done. I stopped because that's as far as I want to go.
Right.
10 is still 5 times 2, 5 times 2. So I end up with this. Everybody will get 2 5s, 2 2s, and a 3.
Okay.
So the prime factorization of a number is sort of like a thumbprint, I don't know, like thumb, but a fingerprint of that number. It identifies that number. There's no other number that has this, which makes sense because when you multiply these, you get 300. Yeah. Let's see what else gave us some trouble. We forgot a little bit about absolute values. Absolute value, negative 4. 4. What about this? So it's not 3 plus 7. Absolute values do not make a part of something positive. Absolute values make the number inside them positive. Or 0. So I can't do it until I know what the number is inside it. So absolute values are like parentheses that have an extra thing. They're not just parentheses, but they also make it positive. So you still have to do what's inside first. And of course we just did that one. Yay. The only number whose absolute value is not positive is 0. Because 0 is not positive or negative. And really, why is it always positive? Because absolute values are based on distance away. How far from 0 is negative 4? It's 4 steps away. You wouldn't say that I'm negative 4 feet away. I don't care what. You're negative 4 feet. What? Am I inside him? Is this another dimension? What the hell's going on? I am 4 feet away. I'm not negative distance. That's weird. Okay. Let's see. Anything else? Let's see. Remember. This is most of what gave us the most trouble. Oh, and of course, here's the nice thing. What's this? 3x. What's this here? You can't make addition become multiplication. You cannot add those. That's it. So it's not a trick question. It's just, do you know like terms? There are no like terms. I can't do anything with this. You with me? I can't add x into y. But I can add x into x. Of course, I can consolidate that. Yeah.
Can you rewrite it like to, aren't you supposed to put the number in first? I thought you said.
Or you can do alphabetical order. Those are competing always. Alphabetical order for the variables is more convention. But can you do anything to this that's not just reorganized? No. So you can't do anything substantial to it. Yeah. This I can do. Now here's the funny thing. Here's the exact same problem. These are the same problem. And I love it when I say that. And everybody's like, okay, this guy's forgot his meds this morning. Yeah. 1 is something plus 2 is something is 3 of those things. I got 1/9 plus 2/9 is 3/9. So why do I need like denominators when I'm adding, subtracting fractions? Because it makes them like terms. You got it? So I don't need like denominators when I'm multiplying. Right? So this will be 3/9, which just happens to be reducing. 1/3. Because they can both be divided by 3. I like it. So if I had 1/9 plus 2/3, now I have to force the other dude to become like terms. They are not currently like terms. So I got to multiply him by 3 to make that 9.
Well, because I thought if you do with the 1/9, you can times that by 3, then that side by 9.
You could, but you always run everything up higher than they have to be.
It's just
The lowest common denominator will always be, it's only ever the product if they don't share anything between them. They both have a 3. That's why this guy just needs one more 3 to make him the same as that 9.
It's just easier for me.
I got you. But I want to save you from when they get really big.
Yeah.
Right? So then you get 6/9, and that'll be 7/9. Cool. Okay. Anything else from that chapter 1 test that was irking you? Yeah.
It's been a while since I've had you.
Oh, yeah. The nice thing about an area of a triangle, I mean, if I call this the base and that the height, so I'm thinking of it like this, right? It's sitting on its base, and that's the height. What would the area of that rectangle be? Base times height. To make a triangle, I cut that in half. Yeah. So the area of a triangle is 1/2 the base times the height. Right? Now, some people might realize not every triangle has a right angle in it, but it works the same if I make a parallelogram. That area is still base times height, and then I cut it in half to make some weird-ass triangle. It's still 1/2 base times height. Yeah.
Could be A, B, H over 2. With the same?
Yeah, you could say area equals B, H over 2. This is the same thing.
Okay.
Yeah. But I think most of us are used to seeing it like that. But it's the same thing there. Cool. That height just has to be truly the height, straight down. So here, if I had this triangle, I'd have to know what the real height is. Not the slant height. I have to know the real height, straight up and down from the ground. Cool. All right. Good. Yeah.
Yeah, I don't know why I couldn't figure out yeah, I can't find it actually.
What was it about?
It was really kind of simple. Is -3/5 divided by -4/5.
Oh, yeah.
For some reason I couldn't get that.
So, do you know the rule for...
Oh yeah, flip and multiply.
Exactly,
Right.
yeah. So the rule for division of fractions is you flip the second guy and you change it to multiplication.
Okay, yes.
So when you divide fractions, you multiply by the reciprocal.
Flip the negative 4/5.
Yep, you always flip the second guy and make it multiplication.
That's to divide fraction, right?
Divide fractions, exactly.
Reciprocal.
Now, in keeping with my theme of you should always question why the hell things work.
Why is that one? Leave it multiplied, right?
So, if I had negative 3/5, now just go with me for a second. I'm never going to ask you to do this, but I want to show you why it works, which forces us to do it in a way we would never do it. This is negative 3/5 divided by negative 4/5, right? Not a way I would ever want to write it. How do I make... Now here's the whole thing. Here's what the whole thing's kind of based on. Let me see if you guys are with me on this. How do I make the bottom... Now stay with me. This is cool, because a lot of you guys have never seen why this works. How do I make the bottom become 1? How do you make a fraction become 1? You multiply by its reciprocal. So if I multiply the top and the bottom, because whatever I do to the bottom, I have to do to the top also. The bottom becomes 1. You guys with me? And it's the same number I started with because I did the same thing to the top and bottom. So negative 3/5 divided by negative 4/5 is the same as negative 3/5 times negative 5/4. That is exactly why that multiply by the reciprocal rule works. If you don't accept it on face value, say, why the hell would that even make any sense? The physical thing, real quick, physical situation, the best one I could think of is, if I knew this box was full, and I saw half of it had 2 oranges in there, how many oranges would be in the whole box? 4. So if I had, if I had one box, and let me see if I can say this correctly. And half of it had 2. How would I even write that? Screw it. I mean, put it all together. That's the best physical situation. If I see one half of a box has 2, there it is. One half of a box has 2 oranges in it. So there's 2 per half a box. So 2 divided by 1/2. How many oranges would there actually be in the whole box? 4. And the only way to make that work is to multiply by the reciprocal. So that's the best physical interpretation I can come up with for dividing fractions. Right? You see half a box, but you know the whole thing is full. You go based off of what you see, so forth. That's the best I can do. This is nice. This is a nice mathematical proof as to why it works. Yeah.
So to solve that one, like 3/5 by minus 5/4, what will be the...
Oh, good question. I like that. Guy in the back's like, let's finish the damn problem. The 2 negatives cancel. And you don't make it 15/20s. You could, but what's the slightly smarter thing to do here? Cancel first before you let your numbers get really big. I can cross cancel. Why can I do that? Because multiplication and division are opposite operations. They'll cancel. So I end up with 3/4. Cool. All right. Yeah.
Could you go over number 31?
Oh yeah, that one's weird because it's got a lot of parts to it, and they threw an absolute value in there. And even on top of that, they got a cube in there. So this is not 15. This is 5 cubed, which means 5 times 5 times 5. Good. So order operation says,
Start in the bits, yeah.
so these absolute values are on the same level as P, right? Order operations, of course, is please excuse my dumbass son. Or dear Aunt Sally. Whichever one sticks in your head better. If I ever offend you, just wait a few minutes. I'll do it again. So, yeah. Inside here, what would you do first? Good. So you can do the exponents. 5 cubed, 5 times 5 times 5. 125. I like it. And what's 2 times negative 8? I like it. Because I know the last thing I'm going to do in here is that subtraction there, right? I definitely want to cube before I subtract, and I definitely want to multiply before I subtract. So I've done both of those things. So now, of course, what can I do?
What number is that one?
Oh, this is number 31. So now what can I do? So inside here I can subtract. Good. So since they're both the same sign, you add them and you put the sign. If I owe him $16 and I owe you $125, thanks for loaning me that. Then I have to add them to see how much money I still owe. I wish I could subtract them. That'd be awesome. My debt's killing itself, but that just doesn't work. I've tried. It just never battles it out. But negative 141, what is absolute value? So here's what you do. The next thing I have to do is that absolute value. So cover this, that's going to stay the same. What is absolute value negative 141? 141. So that becomes 141, and all that is still there. And I know the ones look like absolute values themselves. That's where things get sucky. But oh well. Now what's the next operation I need to do? I've got to multiply before I can subtract. Negative 32. And again, I'm in the same situation. I owe somebody $32. I owe somebody $141. So overall, I owe $173. Good. Yes, sir.
What's the absolute value? So why did we change it from negative to positive? I mean, I know, okay,
Absolute value is defined to be the distance from 0 to that number that's inside of it. So how far from 0 is negative 141? It's 141 spots. You wouldn't say it's negative. I would never use negative in terms of distance. It's down from 0, but it's 141 spots from 0. That's why the shortcut for absolute value is it always makes everything positive or 0 because it's based on distance.
okay.
And distance can't be negative. That would freak me out.
All right.
Go negative 8 feet away from me. What does that mean? I don't want to think about it. Twilight Zone time. All right, so let's get into some lecture. Whew.
I have a question on 43. I like squiggly parentheses on.
Oh, yeah.
That's just like another.
So whenever they do that, it's because they already have, they use squiggly, and then they could use, I don't know if they could use the brackets, and then they pretty much start parentheses over again. That's just so you know which ones go with which thing. If you just use parentheses, you're like, this one, yeah, you go a little crazy. Here you can tell exactly what's holding what. So to do this kind of problem, I start in here and then work out. Because I do inside the parentheses, but in here I got to do inside parentheses, so I always start at the innermost. And I was thinking of like Russian dolls, right? You ever seen Russian dolls with the bigger one, then a smaller one, smaller, smaller, smaller? So go to the innermost doll and work back out. If you don't like Russian dolls, come up with a different thing. Yeah.
What is the difference between opposite number and reciprocal number?
So the horrible thing about the word opposite in mathematics is it could mean two different things. There's a reciprocal. So opposite could mean, you're going to love it. It could mean multiplicative inverse. Oh crap. And that's reciprocal. So we call it the opposite because what's the opposite of 4 multiplicatively is 1/4, because 1/4 and 4 will cancel. That kind of makes sense of what we think of as opposites. Additively, what's the opposite of something? The negative of that thing, right? So if I said, what's the multiplicative inverse of 4? It would be 1/4. What's the additive inverse of 4? Negative 4, because those would cancel. So this whole idea of inverse or opposite has to do with canceling. And so it totally depends on which operation we're thinking about. To cancel when I'm thinking about multiplication, I take division, which is reciprocate. When I'm thinking about addition, I got to make it subtraction. So if I had negative 7 here, its opposite would be, additively speaking, would be 7. If I had 2/3 here, what's its opposite multiplicatively speaking? 3/2. And those would cancel out when you multiply, right? So the word opposite is not enough. If it said write the opposite of 7, you have every right to leave it blank and say, don't take any points off, because I wasn't specific enough. Which opposite? Good. How we doing? Okay. So the very first thing I want to do is talk about probably one of the hardest things actually in mathematics, which is translating from English to math, right? Because we all know that math is a foreign language. You should get foreign language credit for doing mathematics. So if I said something, here's the most evil one. Let's start with the most evil one. 8 less than 8. No. So one mistake I get is this. We put this, mistakes. Another mistake I get is this, and I understand that mistake. It's one word away from that. If it said 8 is less than a number, that would have been right. But this says 8 less than a number. So if the number was 10, what's 8 less than 10? What did you actually just do? 10 minus 8. So what's 8 less than a number? X minus 8. That's the most evil one. That's the one when you're doing a word problem and you get it written wrong and you end up with a garden that has a -7 side length. What kind of stuff are you growing in that thing? Where is that thing? Let me see it. Is it a black hole? I don't know. Anyway, so that's the most evil one. The rest of them are pretty straightforward if you remember what the words mean. So if I said the quotient of 8 and a number, what are you going to do with 8 and a number? What's the operation? Quotient replaces the first two. Yeah, division. So it'd be 8 divided by x, or 8 divided by x. If I want it to be x divided by 8, how would I have to say it? Quotient of a number and 8. Good. What's the word for that means addition? What's some words that would mean addition? Sum. Increase. I like it. Anything else? And maybe. That's a little bit evil because normally and comes after I've set up the operation. So I'd say the sum of 8 and 7. But I could say the difference of 8 and 7. See, and would then mean something different.
More than?
Yeah, you could increase, went up by, anything that, you know, he makes $8 more than this guy. I like it. All right, whoever said that. Plus. And then, of course, you got, I like that, plus.
The product of.
Now what's product mean, though? Multiplication.
It's a good thing we're on over this.
Yeah, it is. I like that. Product. You can see sometimes they'll just say times, but not very often, so don't look for that. Oh, of. Now, this is a good point. Of means multiply when you're dealing with fractions of something or percentages of something. Right, so the word of doesn't always mean multiply, but it means it in those situations. If I say 20% of 300 people, I would multiply 0.2 times 300. That of means multiply. I like that. But you won't see that in like translation problems. They won't really have that too often in there. And the only thing we left out is subtraction, and that one's basically all the opposites of the addition thing. We already did one example. Less than, difference, decrease, you know, all those kind of things. Anything showing going down. Cool. So there was one problem on there. It said something like this here. Let me do it a little bit differently. 2 less than the let's say the quotient of a number and 3.
Number 3 minus 2.
Maybe so. So 2 less than. That automatically tells me I'm going to put a minus 2 at the end. 2 less than something. Now I just got to focus on what's the quotient of a number in 3. The quotient, not product. Yeah. But a number, don't be specific. X divided by, or n divided by 3, or your favorite Russian letter, some symbol, some letter that could mean any number. So when you see a number in 3, be very careful. Don't pick a specific number. You have to use a variable there. So it represents all numbers. Okay.
So using those 2 letters would mean a variable, right?
Yeah, these are the main 2 that you see.
Okay.
X. N in general really actually means specifically 1, 2, 3. N normally stands for the natural numbers, but very often you'll see it used for any number. But when I mean any number, most of the time I use the letter X. Yeah, cool. Okay. That's section 1.1. Section 1.1 deals with translating between English and mathematics. Yes, ma'am.
I was having a question about number 30. When you're dividing with negative, I can't exactly remember what to do with that.
Oh,
You just treat it
we'll get to it. Yeah. But basically, when you divide or multiply with negatives, if you have an even number of negatives, they all cancel. If you have an odd number of negatives, it stays alive, right? So if I had 3 negatives in something, 2 would cancel, 1 would still be there, right? So on the heels of that, people always hate this. What's negative 4 minus 7? Negative 11. What's negative 4 times negative 7? Positive 28. I like it. And people hate that. But negative, I always think negative really does mean the opposite of. We saw that earlier. Negative means the opposite of additively, right? The opposite of 4 is negative 4. So if I have the opposite of, those cancel each other. It's like me saying, turn 180 degrees, now turn 180 degrees, I'm facing it the same damn way. What the hell you want from me? So those 2 operations cancel each other out. When I'm doing subtraction, they're not acting on each other. It's not negative times negative then, right? It's negative and then more negative. So that's why I'm going to end up still negative. I'm down 4 and then I go down 7 more. So 2 very different things. This is the opposite of the opposite of. Cancel each other out. This is I'm down and I go down even more. Cool. People always have trouble. They're like, you just said that 2 negatives make... No. When you multiply, they cancel. When you putting things together, adding, subtracting, they don't cancel. Okay, hopefully. All right, 1, 2 is actually the one that's got the commutative, the associative, and the distributive, and we've already talked about those. I even showed you why distributive works the way it does. So I'm not going to talk anything about that. 1, 3 is about fractions and the need for like denominators and things like that. So I know fractions give a lot of us a lot of trouble. But I'm hoping, if you guys just realize, adding, subtracting, you need LCD. Like terms. Multiplying, dividing, you don't. You just want to multiply, divide, and reduce where you can then, right? But what about, I don't think they do this yet. Not yet, so neither will I. Good. All right. Well, what the hell? How do you turn that into a mixed number? Yeah, carry out the division. And the neat thing is, you can pretty much see that if it was 40, it would go in evenly, wouldn't it? And you have this one extra thing. Well, 40 divided by 20 is 2, and you still have 1 over 20 left. And of course, if you don't like that, you can just still do the same old, the 20 goes in 41, twice 40 minus equals 1, 2 and 1/20th. That whole deal there, right? But I kind of like this idea of just eyeballing and seeing, well, take this down to the number that goes into and see how much is left. That's your remainder that you would see after you did the division. Cool. And how do you go the other way?
Multiply 22, 40, and then add 1.
So if I had this,
7 times 9.
yeah, 9 times 7
Plus 2.
plus 2. I love it. And why does that work? Because what's 7 and 2 ninths really mean? It means 7 plus 2 ninths. And to do that, you need to have like denominator. So I've got to multiply by 9. So that's the 9 times 7. This one's always going to be over 1. So I'm always going to need to multiply by whatever the hell that is. That's why this shortcut works. And then, of course, once I get that, I've got to add the 2 in. So the shortcut is 9 times 7 plus 2, 63 plus 2, all over the denominator. I like it. Cool. Okay. And then this is more getting to the question from earlier. Section 1.4 is all about positive and negative real numbers. So what do you guys think about this? What's negative 1 squared? Which would be 1. And the quick way to see that is there's an even number of negatives that kill each other. So what's negative 1 to the 201st power? Because there's an odd number of negatives. So the first 200 negative ones will kill each other. And the last dude's like, I ain't getting in that shit. So he's still around. So if I add to the 5th power, these two kill each other, these two kill each other, and the picky dude's like, yeah. So it's still negative at the end. So it's really, like you're saying, if I had negative 4 times 3 over negative 7 times negative 8, don't even tell me the number, just tell me is it positive or negative? Negative. How many negatives are there? 3. 2 of them will kill each other, 1 will stay alive. You with me? So then I can put the negative down and not even worry about it. I can just worry about the numbers then. Right? Good. Okay. Maybe. And just to make sure we're all on the same page, we've already done several of these. But what would this be? Yeah, positive 5, because when they're opposite signs, you subtract 9 minus 4 is 5, and you put the sign of the bigger one on there. So if it would have been negative 8 plus 6, 8 minus 6 is 2, the bigger one's negative. There you go. Cool. That to me is the quickest way. I used to try to teach people, if I were 8 foot in a hole, and I climbed up 6 feet, I'm still 2 feet in the hole. Or if I owed you $8 and I gave you 6, I still owe you $2. Right? You haven't completely. Have you ever seen that movie Stand and Deliver?
Yeah.
Fill in the hole. Fill in. Negative 1 plus 1. It fills it in. Hey. So then we get into this whole discussion about real numbers and the different types of real numbers. So, let's see if I can do this a little quickly. This might be something you guys have not really heard too much about. But we start with natural numbers. And I was talking about these earlier. These are the ones that came naturally to us. So I'm a caveman walking around. I'm like, 1 rock, 2 rock. So there's the natural numbers. And this here is a set. When I use that squiggly line stuff, that's a set of numbers or set of whatever. So 1, 2, 3 forever. So that's your natural numbers. Now, of course, especially in today's world, we have to come up with the idea of nothing. So the really neat thing about 0 is it had to be invented. The Babylonian civilization had no symbol for 0. So if somebody wanted 4,007 chairs, they might just get 47. Because they'd have to write 47. Please understand there are 2 zeros. They didn't have a symbol for 0 until right before the civilization fell. Like, we understand 0. Oh, shit, we're all dead. So it's really weird to us. And this is why math is difficult, is because as you learn math, you're actually going through thousands of years of human evolution of thought. It's insane. I mean, a couple thousand years ago, people didn't know some of the stuff you're learning in this class. So it's a lot. So the number 0, we take so for granted, had to be come up with, had to be invented. So once you add the idea of 0, the name of it's really cool. They're the whole numbers. Right? 0 looks like a hole. There you go. So then, here's my caveman. He loses his rock, so he's got no rocks. Right? So you're standing outside the caves, you have a rock. So then he borrows a rock from somebody. So what does he have to come up with now? The idea of negatives, because now I'm in debt to somebody. So when you add the idea of negatives, that's the integers. So all the negative whole numbers, if you add those in, that's the integers. You guys still kind of with me?
Yes.
Again, this is a set of terminology which becomes more important the further you get in mathematics, but we might as well talk about it now. Since we deal with integers all the time, you might as well know that's what they're called. What have I still not included here? Good again?
Fractions?
Fractions, I like it. So Ugg borrowed his rock, he's happy, yay, and he drops his rock and it breaks in half. Shit, now he's got to come up with the idea of fractions, right? Fractions are weird, I can't write them like this. And in fact, the set of things that they describe is called rational numbers. The root of this word being ratio. So that's why it makes sense. So fraction is a ratio. So rational numbers would include stuff like any fraction. How about decimals? What is 0.4? 4/10. So any decimal that ends is automatically a fraction, which is automatically meaning it's a rational number. What about any of these numbers? 3 is rational because 3 is 3 over 1. Any number that can be written as the ratio of two integers, where the bottom is not 0, right? That would be rational. I don't know how deep I want to get into this, but who knows, what 1/3, what is that as a decimal? Does anybody know? 0.33 forever. So that's a decimal that never stops. That's what that little bar over there means, right? It never stops, but it still becomes a fraction. Any decimal that has a pattern to it, 3333, 5555, 27272727 forever, those can all be written as ratios. It's really neat, and I might show it to you next time how to figure it out. But right now I want to talk about specifically, I don't think I talked about this earlier, did I?
Undefined.
Did I talk about it?
No.
And this is good. You guys know it's undefined. Why the hell is it undefined?
Because it goes on.
See, that's kind of like circular logic. It's not an explanation. So I don't know if any of you guys even care about why I like it.
Haunted me forever.
There you go. So here's why we call it undefined specifically. What is 6 divided by 2 defined to be? Because 3 is the number that I multiply by 2 to get. So in order for this to have an answer, there must be something defined that when I multiply it by 0, I get 6. Is anything defined to do that? No, because anything multiplied by 0 is 0. So that's why it's undefined. There's no number defined to do what this says has to happen. This says a number multiplied by 2 is 6. Okay, that's 3. This says a number multiplied by 0 is 6. It's undefined. I see you're still...
I could never remember it, and that's why I always...
I got you, because this...
But now I just remember it as under...
Gotcha. Under, undefined. I like it. I never thought of it. Under, undefined. Beautiful.
That's the only way.
I'm going to start teaching like that now. I steal all my teaching techniques from my students. So I've taught for a long time. The first time I taught, it really sucked. And then I started learning. 0 divided by 6. If I have nothing and I got 6 people that want something, I can't give them any. That's 0. But if I have 6 things divided amongst nobody, not even me, how did I have 6 things then? That's why that's undefined, right? I got all this stuff, and there's nobody here, not even me. I'm gone. That's undefined. What the hell just happened? That can't be. We doing okay? A little bit. All right. How much more do I have to do here? Because now I want to show you this. I don't know if you guys would want to see it. But I want to show you this. If I had the number 0.555 forever. Actually, you want to do something more interesting? Well, let's do this one. Put that. And I want to know, what is this as a fraction? Well, do you know what it is as a fraction? So no. So we don't know. So let's call it x. Because we don't know what the hell it is. Now, what sucks about this number? Why is this number hard to work with? Because the 5s never stop, right? It's repeating forever. But watch this. It's kind of cool. If I multiply both sides by 10, and I'm completely allowed to do that, right? If I do the same thing to both sides. What happens when I multiply a decimal by 10? The decimal moves over. It gets one bigger, right? So now this will be 5.555 forever. If I subtract these two things, won't those forever 5s go away? What's 10x minus x? 9x, not 10. It's 9x's, right? So 9x equals 5, so x is 5/9, which makes sense. 0.3 forever is 3/9. So 0.4 forever would be 4/9. 0.5 forever is 5/9. You got it with me? So if you had 0.2727 forever, what's the one adjustment I have to make? Who can tell? I have to multiply by 100 because I need that forever 27 to match up again. If I multiply by 100, now these forever 27s will cancel when I subtract.
Why is it always over 9?
It's not, but it is always over something related to 9. What's that about?
Yeah.
It's because 9 is just one off from 10, so like 4/10 is exactly just 0.4.
Okay. Yeah.
But 4/9, the answer should be a little bit bigger because I'm dividing by a little bit less.
Yeah.
But 9 is not perfect like 10. 10 works really well. So it just becomes this imperfect 4 forever. That's not the best complete answer I can give you on that, but it's the quickest one that I can answer in a few seconds. All right, how we doing? Is that more than you ever wanted to know about that? Yes. All right. That's neat. No? So, every single one of these is one of these. You with me? Every single one of these is one of these. Can't you find all these in here? Every single one of these is one of these because you just put over 1. And they're all ratios. You with me? But there's a trash pile. This is basically the ultimate here. And then what numbers have we left out? There are some numbers we've left out. Irrationals. Cool. I'm taping it completely wrong way. I need a camera person. These would include stuff like pi, square root of 7, things like that. They are decimals that never end, but they don't have any pattern to them. So I can never do that kind of thing to them. Yes, ma'am?
You're saying that only if it goes on forever and it's a pattern, you can put it over 1.
Exactly. A repeating pattern, to be very specific.
Otherwise,
So if it was 0.345, 345, 345 forever, I could do that to it and make it into a fraction so it's rational. These are irrational. They're just decimals that just look like 0.1829, 35, 46, there's just a bunch of crap, right? You with me? And of course, we all know pi goes forever, right? We all know 3.14, but that's just truncated. It's 3.14159, blah, 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 blah. That's as far as I want to memorize. People memorize like 50,000 places for contests. I'm like, I don't have that much left. No more synapses left open for that. I don't want to take that to forget my mom's name or something for that. No, I got room. Yeah. Okay. I went way far with that. 15016 we've already discussed, and 17. They're all dealing with -2 minus 8, or -2 times -8. Just operations with real numbers, signed numbers. And order operations we basically talked about, but let's... Oh, an exponential notation. I think this will be the last thing we do. So order operation is, please excuse, let me write it like this first. This is the bad way to write it. The reason I call that the bad way to write it is because it makes it look like multiplication must come before division, and that is completely wrong. And I wish to God they would stop. But why did we write it like that then? Because it's easier to say than that. That's PEMDAS. That's PEMDAS. You with me? That's really the only reason. Believe it or not, that's it. But writing it like this looks like, okay, I got to multiply and then no, it's parentheses definitely first, exponents definitely next. Either one of these as they come. Either one of these as they come. That's what it is. You don't multiply before you divide. You do them as they come. So if I had 16 divided by 8 times 3, that is not 16 divided by 24. Yeah.
So I figured in the order of operations, it would be always from right to left.
Yeah, as you read, but not always.
Except for PE.
And AS and MD. So I would definitely multiply or divide before I would add or subtract.
Right.
Right, so if I had, let me add one more thing on here. So the very last thing I would do in this whole thing is that subtraction.
Right.
But I always see somebody make that negative 12. That's not right. It's 4 minus, I don't know yet.
Right. So what I'm saying is that the MDAS always right to left. So you would multiply or divide before you would add or subtract.
Exactly. But as you do both, so like here, what would you do first right here? You division because it comes first.
Right.
Yeah, good. That's what you're saying. So 4 minus 2 times 3, 4 minus 6, negative 2. Cool. And the reason is, it's not fair. What's the 16 being divided by? 8. If you make it 24, it's not fair. Poor little 16. you can't even do that, right?
Right.
All right. Hopefully. And another real quick one is, if I had $4 and I owed somebody 7, that's not a good way to be, right? But I walk around and I find a $10 bill. I should be good to go, right?
Yeah.
You all agree that that statement expresses what I just said in English. That's a good example of foreign language. But if I do this, 7 plus 10 is 17. 4 minus 17, who do I owe $13 to? I'll take it. Right? If you do that, I don't want you near my checkbook. The bank's like, looks good to me. So this can't be right. I have to do it as it comes. 4 minus 7 is negative 3 plus 10, 7. I got that $7 to go buy something with now. Thankfully. And I paid people off so my thumbs stay unbroken. Over $7. That's pretty rough. All right. Got it. Okay. Now exponents, and this will be the last thing for today, I think. Oh, sweet. And that's the end of chapter 1. What are exponents? What do they exist for? What do they represent? What operation do they play well with? Multiplication. So they're based off of the idea of multiplication. They're repeated multiplications that I haven't done yet. So if I have 2 to the 5th power and I want to figure out what that is, I use type 2 to, no. How do you do it by hand? That's right. 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32. Cool. Cool. Now, we're not quite to the point where we're talking about properties of exponents yet. But that's going to come later, and the properties of exponents come right off of that definition. So if I had 2 to the 5th times 2 to the 3rd, and why does that make sense? Because 2 to the 5th is a string of 5 2s, and then I tack on another 3 2s. So why the hell would I do that to myself? Just say I got 5 2s, tack on 3 more, I got 8 of them now. Yes? Say again? Like basis. I like it. Like basis. If I don't have like basis, I can't make a string of the same thing repeated. I like it. Yeah. Oh yeah. So we're going to talk about that later this semester, but And just to give you a little preview, I don't know if you guys know what a 0 power means.
1.
I like it. Yeah, exactly. So coming off of this idea, what would, let me use variables. So like a to the 4th times a squared would be a to the what power? 6. Let me see if you guys understand. There is no 4 or 2 in this. There is no 4 and no 2. There are 4 a's and 2 a's. So people get way stuck on these numbers. They're not numbers. They're how many of these I've got. So I would never get an 8 anywhere in here because there is no 4 and 2. There's 4 a's, 2 a's, so there's 6 a's. You with me? So what do you think happens here? So if I have 4 a's and I divide 2 away, I got 2 left. So I got 4 a's. Those are a's, believe it or not. 2 of them go away, 2 are left. You kind of with me? So here's the very last thing I'll say today, or talk about. A to the 4th divided by a to the 4th, using this idea. 4 minus 4 is, what are you guys saying? 4 minus 4 is 0. But what's something divided by itself?
1.
So there you go, yes. Anything to the 0 power is 1. Except 0. 0 to the 0 power is freaky. 0 to the 0 power is worse than undefined. And that's the most I'll say about it. And that's plenty. That's the most I'll say today. So, if you need an add code, you can come with me to my office.
You would just write A, and that would mean 1A, right? Is that how you like to say?